Yeah, well, I think the girls will be interested. I think the Joey will be a but something is so can't wait to set down
That didn't come out.
Stop.
That's much better. Morning, ladies and gentlemen. How are we doing today? That ain't you guys. Oh, lefty, ladies and gentlemen. 5 minutes, go to work, figure it out. Let's go, let's go, let's go. Figure what out? Figure out that.
Oh, yeah. I should have done it. If I did it, that was actually, I think we will. Okay. Oh,
Jaden Irving, yes. Joshua, yes. Pierce, yes. Angel, yes. Michaela, yes. Maddie, yes. Ben, no. Ariana, yes. Christopher, yes. Jasmine, yes. Achilles, yes. Skylar, no. Joshua, yes. Morgan, yes. Josie, yes. Eric, yes. Steven, yes. Faith, yes. Shenza, yes.
wow. Hey man, it's okay, get the different. You know, my dad probably would.
It's not
Yeah, if it's a left by better right now. Right. What do we? So what do we have to do? Do 1 year to Sunday night trade.
Mr. Brand, is the Wi-Fi working for you?
Semi. Off and on. Slowly.
Okay, I'll have to take it.
Number 11 on your periodic table.
Oh. Oh. So I think Joey's cute. Why don't you make the assumption of me and Joey?
Give it. Yeah, that's well, I'm missing like two.
Y luego consiste eso, consiste en mover y arriba y ellos abajo.
Oh, dude.
I need to put them in the dryer. Straight. So that might be.
What's wrong with the generation? I'm scared.
Okay, ladies and gentlemen, here's what you need to do. You need to take and convert your milliliters into liters by dividing by 1,000. Take it times the molarity, which is 2.11 moles per liter. You are left with 0.202 moles. That's it. Didn't ask you to go to grams. So, you're finished. Questions?
We're doing another one. Not of the same, I think, but like just
What?
another fraction.
Of which kind?
Can we do one from like? So we can go from moles to. I don't know. I think that you have for us.
This angry voice.
It's only their equals.
Wouldn't it just be 0.2?
Maybe, maybe not.
Oh yeah. That's
I mean,
I'll be okay.
Okay, there you go, ladies and gentlemen. How many milliliters of solution are needed to have 1.05 moles of aluminum chloride if the molarity is 4.33 molar? Flip your page over, do this one.
Oh yeah, you did. Because it's 5. Right? Yeah, you did. Oh, 5 Yeah, you gotta figure out.
If you did the last problem, ladies and gentlemen, this is the exact opposite. In the last problem, you started out with milliliters, you got to moles. Now I'm asking you to start with moles and get to milliliters. The exact opposite problem that you just did, you are doing here. The biggest problem I see people have with questions like this, ladies and gentlemen, is this right here. I've said it before and I will say it again. If you will get in the habit of taking this and writing this as 4.33 moles of aluminum chlorate over 1 liter, you will find it much easier to use. You will find it much easier to use. Because now you take your 1.05 moles of aluminum chlorate and you make this into a conversion factor. The problem is right now, where do I need moles? So I take this and I just flip it over. That's all I'm going to do. Put 1 liter on the top. 4.33 moles on the bottom. Moles and moles will cancel out. When you do the math here, you will be left in liters. So that is about 0.250. But it wants you to go into milliliters, so we take that times 1,000. There you go, ladies and gentlemen. Questions? We use molarity to get from moles into liters, or we use molarity to get from liters into moles. This, when it's written this way, can be flipped over if needed. It is a conversion factor. Okay? When we use formula mass over moles to get from moles to grams, we flip it if we want to go the other way. If we're in grams, we put 1 mole over the formula mass to get into moles. That is all I'm doing here. I am flipping this over because I need moles on the bottom and liters on the top. It is a conversion factor. I can flip it. And it will take me out of moles and into the unit of liters. If I use it this way, it will take me out of liters and into the unit of moles. It depends on which one you are going for. Questions? Okay. We left off with this problem yesterday, ladies and gentlemen. This is in your EISN, slide number 17, ladies and gentlemen. This is the problem we were working on when the bell rang. Now, this problem is not a single or a double replacement reaction, so I literally list out all of the reactants involved. Sulfur dioxide, SO2, oxygen, O2, water, H2O, to produce H2SO4, sulfuric acid. Real quick, 2 kinds of acids, ladies and gentlemen. Binary, which begins with the term hydro. Binary means there are only 2 different elements involved. Hydrosulfuric would involve hydrogen and sulfur. Hydrochloric would involve hydrogen and chlorine. Hydronitric would involve hydrogen and nitrogen. Hydro always ends with ic acid. And it always involves only two elements. Hydrogen is always a +1. The other one is a negative nonmetal. So nitrogen, fluorine, phosphorus, sulfur, chlorine, bromine, whatever, we still need to balance off charges. Here, it is sulfuric acid. That is a ternary acid. Ternary acid means turn your periodic table over. Find the polyatomic that this acid comes from. If your acid ends in ic, but no hydro in front, so sulfuric comes from a polyatomic that ends in ate. The closest thing to sulfuric is sulfate. Sulfate is SO4. It has a -2 charge, so we have two hydrogens with it to balance that off. Questions? What if it were an OUS acid? What does that come from? So nitrous acid. What? It comes from an ITE ending, nitrite. Not nitrate, not nitrite. So instead of NO3 nitrate, it comes from NO2. Well, NO2 has a -1 charge, so you would put hydrogen with it to balance it off. We use PV equals nRT to get our number of moles. Volume needs to be converted into liters. Temperature needs to be converted into Kelvin. We do those, we solve for N here. How do we solve for N? Since you are supposed to be multiplying it by 8.31 and 291.7, we divide this side by those two numbers. What we do to one side of an equation, we do to the other. We isolate N on its own side. We solve for it. We get 0.01158 moles. First step in any stoic problem is to take what you're given and get it into moles. Second step is to use the molar ratio. The molar ratio in this case is between the SO2 that we have and the H2SO4 that we are trying to find. So we rewrite this moles. We take it times 2 moles of H2SO4, Y2 because of the 2 here, over 2 moles of SO2, Y2 because of the 2 here. Anyone have any questions on where this ratio comes from? The last step of our process is always to then take that information and get it out into the unit that they are asking in the problem. Since they are asking for grams of sulfuric acid, we are going to use formula mass over moles to get to grams of sulfuric acid. So 1 mole on the bottom, 98.08 grams on top. When we are done, we have 1.135766. A lot of numbers from our calculator. We need 3 sig figs, so that becomes 1.14 grams. Anyone have any questions at all? None. All right. So in a series of reactions that inflate airbags in automobiles is the decomposition of sodium azide. Now you'll notice I gave you the formula there, correct? NaN3. The reason that I gave you the formula there is because sodium azide is not a compound we would know how to name. I have not given you something like that. So therefore I give you the formula. Determine the volume in liters of nitrogen gas produced if NaN3 is decomposed at a pressure of 745 millimeters of mercury and a temperature of 24.2 degrees Celsius. Solid sodium is the other product. So again, I don't expect you to know how to predict a synthesis or a decomposition reaction, so I have given you everything here. So again, we start with NaN3. We break it apart into nitrogen gas. I do expect you to know how to write nitrogen gas. That is N2. And I would expect you to know that solid sodium is Na. Now, this has two sodiums here, or I'm sorry, we had two nitrogens here, we had three here, so we needed to balance that off. I put a 3 in front here to get to 6. I put a 2 in front here to get to 6 nitrogens. I now have 2 sodiums, so I put a 2 in front there. That is the balanced chemical equation. Questions, ladies and gentlemen? Now, where did I get the state from? It says that sodium azide is a reaction that inflates airbags. So this has to be a gas, this is a solid, this is a gas. All of those things are in there, ladies and gentlemen. Again, should be able to figure that out from reading the problem. Don't expect you to know those things. I'm given 100 grams of this. I want to know how much of this is produced. This is similar to the last problem, except in the last problem I was trying to find the number of grams, and I was given the information for a gas. Here, we're doing the opposite. I'm given the information for the grams, and I'm trying to find the volume of the gas. So, again, we take what we're given, and we get it into moles. How do I get grams to moles? Formula mass. Formula mass for sodium is, sorry, I didn't correct that. That is the correct formula mass, ladies and gentlemen. That is the wrong label there. Okay? So 1 mole of NaNO3 over 65.02 grams of NaNO3. Sorry, wrong unit there. Next, I use my ratio. I want to go to nitrogen gas, so that goes on top. 3 moles. I'm getting out of NaNO3 or NaN3, so that 2 moles goes on the bottom, so these cancel here. Sorry, ladies and gentlemen, I will fix this right away for you so that it does not confuse you. Okay, so that's better, ladies and gentlemen. Okay. Now, the reason that I am stopping here is because what am I going to use to find the volume of this? What formula?
PV equals nRT.
And there's no easy way for me to continue that in this method. PV equals nRT is a little bit different formula. It doesn't fit well into this unit cancellation method. So I'm stopping here to get the moles of N2. Now that is going to have to go into PV equals nRT. So that's the reason for this change of me not continuing with another conversion factor here, because there isn't an easy one to do with PV equals nRT. So I'm going to use that formula. Why? I'm given a pressure, I'm given a temperature, I've got a number of moles here. We're going to use PV equals nRT. So I put in the 745 millimeters of mercury that they give me. I don't know what the volume is. I know how many moles of gas I created. I know what the R value is. And I have taken 24.2 and converted it into Kelvin, 297.2. I'm now going to solve for V. How do I solve for V? I divide this side by 745 millimeters of mercury. What I do to one side, I do to the other. Notice units, moles and moles cancel. Kelvin and Kelvin cancel. When I, sorry, should be mmHg, I'll fix that. When we're done, ladies and gentlemen, we get 57.4 liters. Questions? Now, in reality, ladies and gentlemen, we are doing steps that we have been doing in the last 2 units. grams to moles, moles to volume for PV equals nRT. The only thing that we have added here is this step in the middle where we need a ratio. A ratio to get from one part to the other. Questions? Now, all of this is in your notes already. So as we're going through these, all you need to do is follow along. But you've got to practice, and that's what we're going to get to in a minute, ladies and gentlemen. All right. Photosynthesis reactions in green plants uses carbon dioxide and water vapor to produce glucose and oxygen. Write a balanced chemical equation for the reaction. If a plant takes in 245 milliliters of carbon dioxide at 13.9 psi and 26.3 degrees Celsius, an excess water is available for photosynthesis. Determine how many milliliters of oxygen gas the plant would later release if the pressure drops to 13.5 psi and the temperature became 18.7. So on the last problem, we started with grams, we ended with volume. The problem before that, we started with the pressure, the volume, the temperature. We figured out how many moles of gas, then we got it into grams. Here, we're using gas laws twice. Carbon dioxide, CO2, water, H2O, oxygen gas, and glucose. Now, balancing this is a little bit of a challenge, but we end up with 6, 6, and 6 here. That's what we end up with. What am I given? 245 milliliters of CO2 at 13.9 psi and a temperature of 26.3 degrees Celsius. What can I get from these three things, ladies and gentlemen? From this volume, this pressure, and this temperature? I can get moles from that. I'm going to use that to get moles. What formula am I going to use? PV equals nRT. Ultimately, I want to know how much of this gas. I want to know how many liters of gas is produced. Well, I'm given a new pressure and a new temperature, which means I need what to be able to find volume? I need moles. That's what the Stoich problem is going to give me. So PV equals nRT. Everything goes in here. Milliliters becomes 0.245 liters. Please, if you don't understand why I did this, please ask. Temperature 26.3 becomes 299.3. The R value for PSI, I got it right this time, is 1.21. We solve for N. That gives us 0.0094034 moles. I don't care about sig figs. Don't worry about them yet. Leave that number in your calculator. What's the next step? We've taken what we've given and gotten it into moles. What is our next step? Yep. Well, those are called coefficients, but what we're really doing is using the molar ratio. The ratio of what we are going to compared to what we are in. So we're going to oxygen, so 6 moles of oxygen on the top. We're in carbon dioxide, so 6 moles of carbon dioxide on the bottom. Oh, look, the number doesn't change. Why? Because 6 over 6 is like 1 over 1. But you need to show me this step. You can't magically just change the unit. The unit of CO2 canceled out. We're now in the unit of moles of oxygen. Now we take this number, ladies and gentlemen, and go back into PV equals nRT. But we have a new pressure. We have a new temperature. Our new pressure is 13.5 psi. Our new temperature is 18.7 degrees Celsius. Still the same R value. And we now know what the moles is. We are solving for volume here. Divide this side by 13.5 psi. Divide this side by 13.5 psi. Final answer, 0.2458 liters, which becomes 246 milliliters, because that is what you were asked to find in the problem. Milliliters, not liters. Questions? You have got 15 minutes to work on your packet, to do the problems that involve gas laws. Now, if you get to a problem involving molarity, we have not done that yet. I'm not saying you can't do it, but we have not yet done that. So if you want to skip those and go to the other ones involving gases or involving masses, you are welcome to do so.
Can you tell us the numbers?
You can do 1, 2, 3, 4, 5, 6. You can do 8. You can do 9.
Show me.
You can do 10. You can do 11. You can do 12. The only thing you can't do on 10, 11, and 12 is the percent yield. I haven't showed you how to do that yet.
Number 2. How many grams of fluoride?
So this is the N, and you know, we convert this to that. Always put over my
Just kidding. Alright. Wait, would we put 2 here because it's a diatomic? Yeah, I'm putting it in now.
If it's a diatomic and it is alone, you always have to put a 2 by it. If it is not alone, you don't have to worry about it being diatomic or not.
Okay. Well, she's not working, she's doing it.
Did we siren?
Sodium chloride. And then,
Questions?
oh, I'm okay, thank you.
I was confused, so I looked up the
Okay.
and I don't know.
Okay. Okay, so we want to go from moles of hydrogen chloride to grams. So formula mass of hydrogen chloride up here. So 1 plus 1.01 plus 35.45 is 36.46. Now, that may not be the number I have there, is it? Am I even close?
I can reach back and get that one, so.
Okay. And it is very possible that when I did the problem, I copied and pasted from another one, and that's why the answer key may not look correct. So when you run into those, you need to let me know so that I can go through and I can correct them. So which one is that? Which number is that, Morgan? 5? Nope, I should have corrected it. Should be 36.46 in the answer key.
Cause I think yesterday it was wrong and so I did fix it. You may have to update your computer and maybe it's because we have internet issues that it may not be showing you the right one. It may be going to a cached version of it. I don't know. But that number that I gave you was correct, but the answer in that, even though the number might have been wrong, was the correct answer, just so you know. Questions?
You're wrong.
Questions?
God. Couldn't even do one simple thing.
I know.
Why do you put two?
I'm scared. I'm scared. Oh man. Why did you find something that worth it? Joseph,
That's true.
That Lewis is a lot.
Questions? I know. I'm sorry about the computers being slow, but there's absolutely nothing that I can do about that. And that actually isn't sarcasm for once.
Bob the Builder. Okay. Because he can do it all. Yeah. Okay. Hydrogen is okay.
You can watch Joey eat the hot one.
I thought he was eating it at West.
That's what it's made to.
Ooh.
It's their restaurant.
Yeah.
I remember doing it over there. We had a couple of restaurants. So next day, I had to wait for 2 seconds and Joey was already done.
Dude, he eats, bro. That man's like a big boy. He eats. That's not mean or nothing, but like he eats. Wait, is this what you got for your thing? So 2 NaCl2.
She was reward. Freaks me out. Oh, okay, I was right. Okay.
Oh,
Jenza! What can
are
I
you
do for
serious?
sir?
Are you serious?
What?
Wait,
The rest of it's right. It's doing it.
wait, so that doesn't make sense because you don't have the 2 there, and he just said that it's a.
Well, I would have shown you,
Huh?
but I wouldn't show you.
I wonder if it works on my computer.
It's an electric current is passed with the liquefied salt. That it breaks down into its elements. What elements?
Well. Okay, so what would I do? So I have 30 grams of hydrogen.
You got
Somebody
it.
found the last ask.
Can I just take a screenshot?
Ask who says.
I would do just what I did now. Just what I did now. Come, Jeff.
I think we should start
Hey, so we're
saying
gonna-
shucks by Danny, like if something
Why?
goes wrong, just say shucks.
Okay, where's your
So-
balance?
He's so offended, it's hilarious.
Why?
He goes absolutely fair. I don't know why.
That poor little thing.
How do I know if it's still going?
One person can ever. Well, I hope so, because I do.
I think if you have
That
two
poor soul.
Okay. Before I get kicked out, I got a screenshot of this problem. Just look at it. Okay?
To NaCl. I have the formulas right. It's just like
No. That's
This
correct.
is-
Right.
didn't you just say that it should be a 2 there?
How about-
Because it's a diatonic. I mean, I got my balancing right.
I would start with oxygen. Look at it. Okay.
So you did it wrong. And he did it wrong.
No.
Okay, got it. That makes sense. Why did I put N? I meant to put N. No.
The end gets cut.
I know. Happy.
Because we don't practice our ensemble piece anyways.
Yeah, it really has it.
Yeah, but pretty much everything is practiced by solo, so you can't practice it in a practice room because the drums don't fit.
Let's see.
And I practice it very much, but I don't like practicing it out with most people because there's
Why don't you just not mess up then? Hello.
So, what you're getting.
it's easier to
Get it in the
Wait. Then one more of HCl.
That two picks will come into play when we do our ratio. Don't worry about that. So take 5 grams.
Hey, but there's 2 HCl.
Convert it into.
Oh yeah, I was gonna say this. Wait. 2 more, so nice. Oh, you have to use formula?
I have to use it in two spots. Just depends on the spot that I'm doing. Because I should probably write that this is.
That's what you're trying to find. And then 2.
I'm just writing that because I know if I didn't, I was going to forget where I got that number from.
Also HCl. Cl times grams? Or is it, it's 1 mole.
See, what do you do with that now that you got it in the moles?
But the thing is, there is no, yeah, there's no 1 mole of HCl.
What you're gonna get it in the moles.
Or that just, oh wait, 1 mole,
Because
and then I put it in formula mass. Okay, right, and that's grams. Right? Yeah, I was right.
I'm just confused here because what if this one be canceling out? Oh wait, no, because you're.
These grams cancels out here. Yeah, I was like, okay.
I just ignored the
It's not
grams.
that it went anywhere,
It's
it's that a certain amount of this, there's a different amount of this thing.
2 times 36.46.
So that's why we want to get
divided
confused.
by grams. 4 times 2. And you get 18.7. How are you gonna react? Oh, because they're both AQAs. Oh, they're all AQAs, yeah. So you didn't even have to do this.
This one.
So it's down, you can't say where did they all go.
Okay, so now that I take a screenshot, it's not lying on
Okay,
me.
so now you go
Watch the closes and it's gonna
What you get
instantly crash.
3, 2, 1, drop.
Next step.
I'm gonna close out on
It's
you.
going.
Well,
So I need.
You're missing something before you can figure out how many moles of this. For what?
wait, in a double replacement. Wait, in a double replacement, it all means that it's aqueous, right?
Now converted into moles
Is that what it
of oxygen. Yes. is using the ratio from.
Because if that's the case, it just gave us the answer to the question.
Right?
It's so complicated.
Now figure out how many moles of oxygen you created. So,
Left hand speed.
Seven.
she wants it in what unit? Liters.
207.4. 207.20.
Yes.
Phosphorus
It's tiny water.
2. 38. 96.
Grams per 2.
Oxygen times 8.
So what's the relationship of the volume to moles to this tiny distance?
Bro, what's the point of Spanish? Bro, it's Spanish, supposed to focus on Spanish.
1 mole equals 22.4 liters. So you're right, Josh. Normally we go into EV equals NRT. But because it gave it to you at SQ, we have a simpler way of doing that, which is 1 mole of gas.
We just skip to it and say, where's this no reaction?
Bad move.
But it's because
At SQ, it doesn't matter what the gas is. 1
PV,
mole
where's
versus
PV? Okay, there's no PV. PO. So NH4 getting out of group 1. So.
All right, ladies and gentlemen, come on back so we can take our quiz.
Let's go.
Clear your desk of everything except for your periodic tables and your calculators.
Oh my god.
Please remember, show your work, show your final answer in sig figs with the proper unit.
You're that nervous. This was for ice.
All right, quiet, please. Till the test, till the quizzes are done. Come on. If you have questions, ladies and gentlemen, please call me over and ask me. Otherwise, good luck to you.